Hi everyone, this is Venkat and welcome to Hashtag channel. Today is the day 2 of Unix and Linux fundamentals. So today we are going to talk about processor, how it is works, and what processor types we have in the market and how do we choose and all. So without wasting of our time, let's get started. So we are going to talk about day 2 topics that are going to cover today. So first we will go over what is processor and how it is working behind the scene. Then we will go over processor architecture. So what happened when you enter something, then how it is, how the particular thing is processing or the flow of it. And we'll understand the different process architecture that are used in real world use case, right? So we'll talk about more details in that, and we'll talk about a binary, or it's known as a bit. So what is bit, and how do we use by that CPU behind the scene, and how it is working in digital computing system. So before we deep dive into different processor architecture that are available in the market, so first we need to understand what is processor. So we all know the definition or the short form of CPU mean for central processing unit, right? So a processor is a key component of computer system responsible for carrying out instructions of computer program by performing a basic arithmetic, logical, control, and input and output operations. So when I say instruction for a computer program means it will take the instructions from the memory and it will try to do some of the operations called arithmetic or logical and control and input and output related operations. So it is often we referred as a brain of the computer because CPU is the only one that controls everything in the system, right? So the processor in general interrupts and executes instruction from the computer's memory. As I mentioned before, it will take the instruction from memory. When I say instruction from memory, let's say you execute some ls command, so that is processing through the memory. So memory will say that, hey, the user is asking for ls command output. So that's something, get the instructions from the memory. Then it performs the tasks such as calculations, data manipulations, and managing the flow of data within the system. Means how data needs to be flow or between your memory, CPU, hard disk. All is something controlled by the CPU. But all these instructions comes from the memory itself, right? So in general, right, in the modern process of design with a multi-cores. So multi-cores means we have a one processor with a different cores inside that CPU, because it's allowing it's allowing to execute a multiple tasks simultaneously. It's nothing but multi-threading because it improves a overall performance. Let's say you are running a high-end applications and you need a high CPU, and then you require a minimum CPU, right? Let's say example, you are running some Oracle database that requires 8 CPU, then you have a 4 CPU example. But while you try to access that Oracle application, whatever, you will be getting, or your performance, the application performance is going to be degraded because the actual requirement is 8 CPU, but your system is having 4 CPUs. So that's the drawback for your applications. So in general, right, so whatever we installing or we configuring in the server side, that we need to decide like how much CPU is required. So how do we get the CPU and all? Before, the architect who are designing that application design or database design, they need to calculate the uh, past matrix. When I say past matrix, let's say the customer is in right now, uh, let's example customer is in on premises. Okay, so now the customers needs to be moved into the cloud. So then what architect team or architect is doing that, he I mean here who are from that team, they will go back to the on-premises team. They will get everything. When I say everything, they will get matrix about the past 6 months of that particular application or database in terms of matrix or any graphs like that. So based on that, they will decide how many CPUs required on the cloud, or else they will also consider whether they need to be uh, downgraded the CPU or upgrade the CPU. Like that, they will consider it when they are trying to migrate their on-premises applications to a cloud, any cloud. It can be Amazon, Azure, whatever. But in general, let's say in your on-premises that application is running with a 4 CPU, they they might or they mostly try to match the same value on the cloud as well. But sometimes they might need extra because of the application popularity. Let's say Instagram. Let's say example, they are moving Instagram application from on-premises to cloud. Obviously, the end users are, I mean, the Instagram, how it is trending nowadays, right? So obviously, the Instagram app need to be serve the content for the end user. So that time they need to decide, okay, my CPUs maybe not sufficient for my end users. Maybe I need to have the better CPU. Okay, better CPU or better CPUs that need to be hosted uh, for my application. So like that, they will think about it. So when they are migrating, there are two ways. If it is a static application, and they are not going to bother about it. But if it is a dynamic, means every time it is I mean the application is due to popularity, it is going up and down, then they will consider a auto scaling method. So the auto scaling will automatically increase the CPU or CPU, I mean the instances, sorry, not CPU, instances count for the particular application. Then it will bring down the whenever there is no load in the applications. That's how they increase the behind the scene. So that is one example. But in general, the architect who are designing that application hosting on the cloud, they need to decide how many CPUs is required to run that application smoothly. Okay, so that is the reason CPU is a crucial part of deploying a application into the cloud or anywhere in the network, right? So in general, uh, the speed of the processor, right? Generally, it's measured in megahertz or hertz. So other factors like we need to consider while you using or while you opting for a new processor. Example, cache size, architecture, number of cores also contribute to its overall capabilities. So processor a critical component in determining the overall speed and performance of computer. So when I say critical component to determine the overall speed and performance of computer, that means, as I mentioned before, to run our application smoothly, processor is one of the critical component while you before you go into deploy something in the real environment, right? So you need to understand what is the first commercially product launched when it comes to the processor microchip processor category. So the first commercial product is launched by Intel in 1971, and that's one of the model. So you can see here model is P4004. That's one type of CPU model that is something introduced in the late 1971. So the idea is to provide some calculation purpose, some arithmetic purpose, or manipulation purpose. They introduced it, but later on, I mean, Intel is uh, uh, Intel is discontinued the support or manufacturing this particular model, because in the market right now, whatever processor we are using, those those are maximum 64 bit processor. So we'll talk about what is 64-bit processor and what is 32-bit processor in a while. Okay, so this is something designed by Intel, as I said, and discontinued in x81. Later on, Intel, not only Intel, there are many other manufacturer companies like AMD or IBM. All these are introducing different processors for different use case. Okay, so now let's take a high level processor architecture, right? So you need to understand this how uh, the processor architecture is working behind the scene. Means uh, we talked about a CPU will take instructions from the memory to execute so and so program, right? Like arithmetic operation, input output operations, or anything. So how it is done behind the scene. So this is something you don't need to take understand entire this stuff. Just you need to understand how the logic is happening behind the scene. Again, this is something for your knowledge purpose only, and nobody is going to ask what is the processor architecture like that while you are attempting any interview or anything uh, anything you attend in the interview or whatever, right? So this is the processor architecture. So let me check the laser pointer. Yes, so here, right, the input, right? So this input, right, the black lines indicates the data flow, how data flow is happening. Let's say you enter a ls command, so that ls command, how the flow is happening uh, before it's giving some output to the end users. So this is what the input. So this all black lines indicates the data flow, how the data is flowing. And in the red lines, right, wherever you see the red line, those are like a control flow, like how the data, I mean whatever the input is translating in between the components. Like this is the CPU. Under the CPU there is a control unit, there is a registers, small registers, and some logic is behind in that processor, and finally is memory. So we talked about memory will give the uh, instruction or control for how the particular input need to be executed and provide the output to the end users. And finally the arrow symbols, right, wherever you see this arrow symbol, that's indicates the direction of the flow. Means you are asking something and the flow need to be go through, right? It will go through the all these components like control unit, registers, and some logic. So the logic will something handled by the processor only. Then finally user will get the uh, actual output of that particular command or application or program. So this is what the high level processor architecture. As I said before, nobody is going to ask or nobody is going to take care about the processor architecture. This is something you just need to understand how the data flow is happening in between. That's all, right? Next, we are going to talk about in the market. We have a different type of processors. I mean, the processor and processors family. When I say family, it can be a Intel or it can be um, AMD or it can be IBM. There are lot many more in the market. But what you need to understand from this, right? So in general, in previously we have a uh, 32-bit processor. I mean, before 32 processor architecture in the market, late 80s and 70s or 90s, we have a different processor architecture like 8-bit supporting processor, 16-bit supporting processor, 32-bit supporting processor, and latestly the one we are using right now in the market, that is 64-bit or 64-bit processor architecture servers we are using. So what you need to understand from all these 8-bit or 16-bit or 32-bit and 64-bit, commonly right now, as I mentioned, the 64-bit is very popular. And why it is very popular, you will get by end of this particular video or the slide, right? I will talk in detail, but before that you need to understand what kind of processors we have in the market from starting onwards. So but here I'm targeting only a 32-bit and 64-bit processors only. But in the market, like in the past, we have a 16-bit processors also, 8-bit processors also. I'm not considering about that because nobody is used or nobody using right now those architect of CPUs or servers. Always we are using a 64-bit processors right now in the market. Okay, so in general, right, when you I mean, let's say if you are in the IT late early, like 90s, between 90 to 1998, like that, you might be seeing some CPUs or servers with uh, i386 processor. So in the right side you can see the i386 processor, how the processor image looks like. So this is the one of the most successful processor, that's something launched by the Intel in the year of late between like 90s 80 and 1990. So in these years, right, so this is the very popular processor that was launched or created by the Intel company. So generally the processor full number is 80386. So because of 80386 series is very popular, what Intel it decided, they just cut down the first two letters like 80, and they added I. So here I is like Intel. So that's the reason we call it as i386. Okay, so that is the reason we are most likely we are seeing that i386 processor or something like that. Okay, so since it is released as a 32-bit microprocessor architecture, I mean they created as a 32-bit purpose only. So what is this 32-bit and 64-bit? I'm going to talk in a minute. Okay, so next it is discontinued since due to another different processor architecture that are implemented by the Intel. So they keep on introducing new CPUs in the market. So this is something discontinued in 2007. So nowadays Intel is not manufacturing any 32-bit um, like this in the market. They always try to launch their processor in 64-bit uh, 64-bit supported processors only. So when we say this 32-bit microprocessor architecture means that supports 32-bit addressing and instructions, means it will take only a 32-bit instructions, right? So what do you mean by that? So in 32-bit system, right, each memory address is 32-bit wise. So we'll talk about more in bit what is that in a moment. In general, in the 32-bit processor, each memory address is 32-bit wise and allowing the process to access 3 to the power of 32 different memory allocations. I mean to say approximately 4 GB of RAM, right? Because of this particular drawback, Intel is introduced, or because of this drawback, uh, customer might go to the 64-bit uh, processor. So why they are going to 64-bit? Because the 64-bit processor supporting more than 4 GB of RAM. So in generally your programs whatever you run, right, that may require more than the 4 GB memory. Let's say if you hosted your uh, application or database whatever with a Intel or AMD 32-bit processor, and that application just can utilize max 4 GB memory only, means you cannot go beyond that. That's the reason, that's the drawback of it 32-bit processor. So that is the reason what people are who are hosting their applications in the cloud or in the on-premises, they always go with the 64-bit supported processors. Okay, why? Because it supports more than 4 GB of memory for doing all your tasks smoothly. Okay, that's one of the drawback of 32-bit processor. That's the reason people are enhancing their applications, they're growing, so they always need a better performance. So that's the reason most of the people are opting for 64-bit um, processors only. Okay, so because of this drawback, it is discontinued in 2007, as I mentioned in the slide. So we have a different manufacturer who creates this kind of 32-bit processors, like Intel in the market. AMD is one of the top leading company. IBM also another company, right? So yeah, this is the main differences on the i386 family. The next we have a i686 is another processor. Again, this is also implemented or introduced by the Intel company. So Intel Pentium Pro or Pentium series. I mean, we have a different Pentium processor also, like Pentium Pro, Pentium 2, or any later models. All these are comes under the i686 as a 32-bit only. So this is something like extension of your i386 processor, I mean architecture processor. Again, it is also a 32-bit based processor, but it is specially designed for P6 microarchitectures. When I say P6, it is fall under the Pentium processors. Okay, so it is similar to the i3 I mean i386 processor only. Okay, there is no differences at all, but it's specially designed with the Pentium processors only. That's only the difference. Other than that, nothing more in it. Again, it is launched in 1995 for especially for the Pentium models. Then after this is also somewhere in 1998 it is discontinued. Because discontinued, when I say discontinued, means the Intel is no more supporting or no more manufacturing that kind of processor at all for the end users. Okay, so this is the main differences between the Intel 386 and Intel i6 8 processors. So nowadays we are not using these two models as I mentioned, because everyone is using a 64-bit uh, processors only. Okay, let's talk about 64-bit operating system. Sorry, processors. So in the market right now we have a different companies. They create their operating system, they're manufacturing their CPUs in a different ways. So here x86 is one of the Intel family again, right? So it is initially, as I mentioned before, x86 is refers to the 32-bit instruction set architecture used in many Intel and AMD processors. Okay, so sometimes this we call it as x86, or some people are call it as x86 underscore 32. Both are same. There is no differences. Okay, so just you need to remember x86 is a 32-bit architecture uh, uh, that is used in the Intel and AMD processor. So so here X means what? What do you mean by this X? So X stands for the various manufacturers. As I mentioned, the processors are designed by the different companies like Intel or AMD or IBM, right? So yeah, so initially all the series like 80X, 86 or 8086 family, this processor falls under the x86 architecture processor. So because of this popularity or some other benefits from this, then they rebranded or whatever, they just sorted out this name with x86. They just cut down the 80 and then they branded it as x86. That's the reason we call it is x86 as a 32-bit uh, processor. Okay, so the programs or OS is designed for x86 labeled as a 32-bit. When I say programs, let's say some application, you might, I mean, when you try to download some X software, that will give you two options. You need to download with a 32-bit or 64-bit operating system. Then you need to consider 64-bit only. So why 64-bit? The 32-bit operating, the 32-bit software or program or applications can be installed in 64-bit. But if you download the 64-bit software or uh, program or application, that you cannot install in the 32-bit, because that's the drawback of 32-bit processor, right? Because you cannot run a 64-bit application or programs in the uh, x86, which is a 32-bit. So that is the drawback of x86. And the next, they have done some enhancement behind the scene and all. They introduced the x86 underscore 64. So this is the underscore actually. There is a typo. So just remember it. So x86 under 64 is nothing but is a 64-bit architecture. So all these right now what we have in the market like AMD, they have AMD 64, or Intel, they have Intel 64, and uh, sometime we also this we can call it as x64. You can see here x64 also we call it as a x86 platform, or x86 underscore 64 also is a call as 64-bit processor platform, and AMD like this, right? So as I mentioned, in a 64-bit system, right? Processor system, each memory addresses is a 64-bit wise, so allowing access to much larger amount of memory, like 2 to the power of 64 addresses. So theoretically, it is up to something like 18.4 million TB of RAM. That's the advantage of uh, 64-bit operating system, right? So whereas in 32-bit processors, right? What is the drawback? We just access or replace the memory 2 to the power of 32 means that something like 4 GB of RAM, like that only. But in x86 64-bit processor architecture, you will get 2 to the power of 64. That means 18.4 millions of terabyte RAM. The applications or the program um, can be usable. So because of the high memory, and the memory is replacing by the processor, you will run your application or program very smoothly. There is no, you will not get any um, degradation or slowness or something like that, because memory and CPUs are important to run your application smoothly on the cloud or in your on-premises environments. So that is the reason the people always taking a 64-bit processor followed by the 64-bit operating system only. So what you need to take away from this particular slide is you need to understand what is the difference between x86 uh, 32-bit processor and the 64-bit processor. If somebody asks you what is the difference between 32-bit processor and 64-bit processor, you need to tell that in the 32-bit processor, its max it can utilize a 4 GB of memory only. And the second point is we cannot install any 64-bit application or any program in the 32-bit CPU, whereas in 64-bit processor quite opposite, means we can have a memory usage of like 60 more than 18.4 million TB of memory. And the second point is we can install either a 32-bit applications or programs, or we can also install a 64-bit applications and program on the 64-bit processors. This is the only one difference. And as I mentioned, nobody using now a 32-bit processor. Maybe there are some legacy applications still out there, but they might using. But I'm sure now nobody is using 32-bit systems or processor anymore, and all manufacturing manufacturers like Intel, AMD, or IBM, they always try to build their processors with a better performance purpose, better use case for the applications performance purpose. They always try to enhancing the processor threadings and all, right? So just remember, a 64-bit is the only one right now everybody using around the world. Okay, so now we need to understand what is bit. So what is bit means, like example, before I deep dive into that, you need to understand, um, let's say we are giving some input to the system, right? Uh, let's say I'm running some ls command. So ls is a listing of files, okay, in general. So I'm giving ls to the computer, my system, and that will process behind the scene. I mean, that will execute within seconds or within fraction of milliseconds. So we cannot see that process. So as a human or as a person, we know ls because ls is a command we know. But how does this CPU or memory understand that language? It can't understand our language. So that's the reason what will happen, whatever we enter the commands, or we ask some, I mean, we gave some input to the system, that will convert into a binary digit, right? So uh, uh, bit is nothing but a basic unit of data and information storage. When I say unit of data and information storage means whatever we give as an input, that is the information to the CPU and memory. So what will happen behind the scene? It will convert that input into the binary format. So what is this binary? How the values are coming in? How, I mean, where to get these binary values? Uh, I mean, what is the process like that? I'm going to explain in this particular slide, right? So as I mentioned that it's a basic unit of data and information storage, right? So 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 generally, uh, in general, it can have two values, either one or either zero in the number system, right? So this bit is the fundamental building blocks for a digital computing, and it is used to represent the smallest unit of information. When I say information, ls is one kind of input as information. So in the digital computing system, this is a fundamental block for doing that particular task. So here the term bit is often used to describe the architecture of processor in the terms of its word size, which is the number of bits that can be processed in parallel in this CPU. Example, a 32-bit processor can handle a data in 32-bit chunks. So when I say a 32-bit chunks, it's the smallest portion or smallest information. And if it is a 64-bit processor, can handle a the data in 64-bit chunks. Means let's say you enter some content that will divided into 64 chunks. Chunk is something as uh, smallest information about the particular program or command, whatever. So the word size is a crucial aspect of a processor architecture, influencing factors like memory addressing, data bus width, and overall system performance. As I mentioned before, if you have a good processor like a 64-bit processor, your life is very smooth because the 64-bit processor will give you the best performance in the world as of now. Maybe in the future, this Intel or AMD or um, IBM, whoever who manufacturing this processor, they might extend that 64-bit capability to the next level. We don't know at this moment, but at this moment, the 64-bit processor very useful. So in addition to that, right? You may also encounter related to some kind of you might hear some of the names called like bytes. So bytes is nothing but 8 bits. Sometimes you might hear enable 4 bits. Yeah, and words. So all these are something processor architecture. All these words or terminology comes under the uh, processor architectures only. Okay, so when I say this binary number, either we have only a 0 or um, we have a 1. You cannot get any binary values like 2, 3, 4, 5, 6, something like that. So always these binary digits either you might find as a 0 or 1s, not other than two values. Okay, so example, I am taking one example. So let's say you are giving some command. Sorry, in this case, like number. Let's say I'm giving a 50. Hey, system, can you process this 50 as a number? So, as a people, as a human, we know 50 is the number. Like we know the it's a number, but system can't understand that. So, behind the scene, this particular number is converted into the uh, binary mode. So binary, how it is converted, how do you know like how do you know this particular values assigned to that, and all these something I'm going to give the full clarity in next few minutes. Just understand this slide. Okay, so the number means, as you know, we are the humans, we know that 50, but system can't understand. So what it does behind the scene, it will convert that into the binary. So how this binary value comes from, where it is comes and all, I'm going to explain. The next is, let's say you entered some word called hello. Not only hello, let's say you enter your name or any commands or whatever, that will also is converted into a binary, because CPU or memory can't process our human readable numbers or words. That always, the CPU or memory always understand these uh, I mean this inputs in a binary format. So in this case, hello is one of the word that we provided as an input to the CPU. Then CPU will get that hello. I mean convert that into the binary with this much of number. So let's understand that how these values are converted from either number to binary or words to binary. Okay. So we have a good in the Wikipedia, we have a good documentation where it describes about the how the binary formatting happening behind the scene. So all these ASCII values are something already there in the Wikipedia. We just need to go and check. When I enter something as a decimal number, then what is that for the decimal number, what is the binary number it's assigned. So that you can get it through the ASCII. There is a good documentation which is available in the Wikipedia. I will show you. So I'm going to take one example here. Let's say now convert that 50 as an example and convert that into the binary format. So how you can convert this? So this 50, right? Take not only 50, take any number, either 10 or 60, 70, any, take any number, your wish. So in this case, I'm taking as number as 50. So how does this 50 value is having this particular binary number? How it is calculated behind the scenes? The CPU, how it is um, converted that into the binary. So there is a logic, right? So what you need to do, take the 50 as your number and divide by 2. You need to divide your number, not only a 50, take any number, just divide with a 2. So you will get a 25, and you just need to remember this remainder. So this remainder is 0 now. So how it is allocated as a 0, and I will show you in a minute from the this page. Okay, just understand this particular 50 and its conversion to the binary mode. So Like this, you need to convert, you need to divide that value by 2. Okay, let's say 5 divided by 2 is a 25, and take this 25 value, and 25 divided by 2 it will 12, and 12 divided by 2 it will 6, and 6 divided by 2 3, 3 divided by 2 1, 1 divided by 2 0. So you need to divided that value till the 0. Okay, till the 0. When you get that 0, then your binary format will generated. So this is one of the example. So now I'm taking you to the Wikipedia page, and we can get this information too. So you don't need to get this logic and all, but I explain like how the uh, binary formats are created behind the scenes. So while you creating or getting this kind of binary, you need to always remember, you need to uh, club the values, I mean reminders, from bottom to top. So for say 1 1 0 0 1 0, so here first 0 is ignorable, but in the Wikipedia we can get that information as well. Okay, so now I'm taking you to the um, Wikipedia page, and I will show you the same value. Okay, just remember it's 0 double 1 double 0 1 0, right? Same we will get the same thing from the Wikipedia as well. So let me go, and my number is 50. I'm moving to the slide. Yes, I opened it already. Just come down. So in this slide, right, what you need to just look at from this slide is, I mean from this Wikipedia doc is, just you need to look at the character section and come down bit. I will explain in a minute. And you need to just look at the control code chart. So in the control code chart also, you need to see the decimal number. So just decimal number, concentrate on the decimal number and the binary number. So now let's go back to this one, right? So we talked about number 50, right? So just go down and look at the decimal number. Where is the 50, right? Just come down and see the 50. Look at this 50. So this is the decimal number we given to system as an input as 50, but behind the scene system does this 50 to a binary format with this number, right? You can see the same value in my slide as well. I'm going back to the slide. My slide also is having the same number, 0 double 1 double 0 1 0, right? See, 0 double 1 double 0 1 0. So these values are already predefined, so you don't need to calculate anything. So as soon as you enter your decimal number or number, that will converted into the binary. So every letter in the system that has its own unique binary number. So you don't need to remember the binaries and all. So why I'm discussing all these things are because you need to understand system or CPU can't understand the human readable language. It always converts uh, our human readable languages into a binary mode. So how does that binary modes are coming into the picture? So with this particular Wikipedia, we can get more information, right? So this is one example for converting number into a binary. Now what about if you are entering a word, like a word? It can be anything like hello, hi Venkat, your name, my name, or my channel name, whatever. So that also is going to be converted into a binary format. So here you need to understand it's a case sensitive. So small, there are capital letters or there are small letters. Based on that, these values are getting generated. So now break down this particular um, word into a binary mode. So, so here capital H, right? It's a letter. Ask is one of the letter. I mean H is one of the letter. For the H, there is a number. So this number is your decimal number for the particular letter. So how can I get that? Again, you need to go back to the table, the Wikipedia page. Just go back. Now this time you need to, when you are dealing with the characters, you need to check this table, character sets. Okay. So now, what is the first letter? It's a capital H, right? So you need to go here. Just move your cursor here and there, and you will be seeing a 72. I mean, under the cursor, you might maybe seeing the 72. So that's the decimal number for the H letter. Okay. Now you know the decimal number for H letter. Now you need to go back to the table again, the decimal number, I mean control chart, and look for the 72 number, right? See the 72. So this 72 is having this binary code. Okay, 100 and 1000 is the H letters binary code. Now go back to the slide and see, I mentioned it as a red, I mean for the sake of giving a best visibility. So I given it is 100, right? So like that, every letter, every single character, not only letters or special characters, they treat as some code. Okay, that code is nothing but is a decimal number. So that decimal number has its unique number, I mean binary number. Now go back to E letter. So the E is having 101. Okay, again you need to go back to the table. It's a small e, so you need to just move the cursor here and there, and you will be getting a value with 101. You can see that value here also, right? And in the cursors, bottom of the cursor, you can see it's 101, and after that you can ignore. There is a U plus 0065. Those things you can ignore. Just you need to concentrate on the first number, like 101 from the particular letter. So now go back to again into the slide 101, 101, right? Page, scroll up. Yes, you can see the 10. So this 10 is belongs to E letter, and the E is now is having the binary code is this one, 1100101. Now go back to the slide, 1100101. So like that, every ASCII letter or any special character, everything that gets converted. So this is how, as soon as we enter, these values are, I mean these binary formats are gets created or executed within within seconds or within milliseconds. You can't see this process um, in the screen or whatever. It will happen behind the scene, and it does on the, I mean this all operations does on the CPU level, right? So generally the binary representation is often known as a fixed number of bytes. So generally it's start with the 0. I mean I mean initially I told you that either we have a 0 and 1. Okay, uh, the binary numbers. So when it comes to the when it comes to the these numbers, I mean to say the decimal numbers from for the binary format, it's always start with a 0 and with a 127, right? So you can go here and check in the slide. Start with the 0, it's end with a 126, means 0 also is countable, so it's 127. So you will not get more than that value. So any value that is having at 126, that value will be getting this particular binary number, right? Yep, that's it. I hope you got the clear idea about this. So that's it for the day. So I hope you like my day 2 session where we discussed about the processor and different processors like 32-bit and 64-bit and their differences, and finally the bit operations, how the bit, I mean binary operation is happening behind the scenes. So if you like this video, kindly comment, like and share and subscribe to my channel. So you can follow me on my official page like Facebook and Instagram channel and hashtag channel. I mean Telegram where I can post my content wherever is applicable. So that's it for today, and thank you all.